I'm going to do an example of testing a claim about two dependent sample means, dependent samples. And in this kind of an example, they'll give you a list of paired data, which is a dead giveaway that this is an example of testing a claim about two dependent sample means. And there's three kinds of examples that the first list is bigger, or the second list is bigger, or the lists are the same. In the homework, they ask questions about the lists are the same, so I'm going to give an example of that. So here's an example with alpha equals 0.05. Test the claim. These data are from populations with the same mean, and it's the blood pressure in the right arm and left arm. And here's the paired data, the right arm and the left arm. So for the right arm, the measure is 114, 116, 120, 108, and 112. And the paired data from the left arm, 106, 109, 119, 112, and 115. These are the data. So like all hypothesis tests, there's three parts. Number one is the setup. And since we're testing the claim that these populations have the same mean, the claim is that mu sub d stands for the difference in the population means. If they're the same, then mu sub d would be 0. The opposite is that mu sub d is not 0. The null hypothesis is mu sub d equals 0, which is from the original claim. And the alternate hypothesis is mu sub d is not 0, which makes for a two-tailed test. Okay, so the main thing about this is how to mess around with the calculator for this. And so I want you to follow this closely. So on the calculator, I'm first going to we're going to enter these data into lists. So the first thing I want to do is clear out anything I might currently have in the lists. So I'm going stat, clear list, and then I'm going to hit L1, comma, L2, comma, L3. We're going to use three lists. Remember the L's are above the numerals 1, 2, 3, and I have to hit the blue shift key to get them. When I hit enter, done. Now I want to enter the data into list 1 and list 2. I'm going stat, edit, and in list 1, I'm going to put in the right arm data, which is 114, 116, 120, 108, 112. In list 2, I'm going to put the left arm data, 106, 109, 119, 112, 115. And then I'm going to get the differences into L3 I'm going to arrow up to the top L3. Notice how it's highlighted there. And then I'm going to hit enter. And then down on the bottom, I can write L3 equals L1 minus L2. And that puts the list of differences into the list L3. That's the list that we're going to do the test on. So I'm going to go to stat, tests, t-test. Okay, and I'm going to do this t-test on the data. So I'm going t-test, and I'm using the data option. as opposed to the stats option. And then mu null, the null hypothesis is the value 0 from the null hypothesis. The list that we're doing this on has to be L3, which I have in there already. If it's not there, put it in there. The frequency is 1. We're using each data item once. Mu, and here you want to match the form of the alternate hypothesis, which was not equal. So I want to make sure the not equal one is highlighted. This one is the one that's highlighted. Less than or greater than would be for left and right tail test, but this is for a two-tail test. And then when I hit calculate, it gives me the two important values here are the t-value, 0.72647264. That's what's known as the test statistic, which the homework will ask you for. And the all-important p-value, about 0.5078. 0.5078. That's the p-value. So that's doing the calculator. And then the third step is drawing our conclusion. And the conclusion is, since p equals 0.5078 is not less than alpha 0.05, that means we fail to reject H null. Going back to the setup, H null was from the original claim. And if you look at the wording conclusion chart, fail to reject H null from the original claim, the conclusion is that there is not sufficient data to reject the claim.